In this lesson, we are going to talk about the primary trigonometric ratios. In fact, we are going to upgrade our definitions of the primary trigonometric ratios from grade 10. So before I teach you the new definition of the primary trigonometric ratios, we're going to talk about the old definitions. So the definition for sine, cosine, and tan from grade 10 were derived from the right triangle. And there's nothing wrong with these definitions. They make perfect sense based on what we were doing last year. So sine is defined as the ratio of the side opposite to a given acute angle in a right triangle to the hypotenuse. Cosine is the ratio of the side adjacent to a given acute angle in a right triangle to the hypotenuse. Lastly, we have tangent, which is the ratio of the side opposite to a given acute angle in a right triangle to the side adjacent to the same angle. And we would summarize this very quickly by saying SOHCAHTOA. So that acronym was to help us remember the definition of sine, cosine, and tangent. So why do we need to upgrade the definition of sine, cosine, and tan? Well, based on what we're going to do for the remainder of this unit, and especially in the next unit when we study trigonometric functions, this definition doesn't work out. So why does it not work out? Let me give you an example. Sine of, I don't know, let's say 156 degrees. Okay, so based on our old definition, sine 156 degrees makes no sense whatsoever. Okay, how do I have an acute angle of 156 degrees? It just doesn't make any sense. So if it doesn't make sense, the calculator should give me an error. But it doesn't give us error. It actually calculates a value for sine 156 degrees. And what the calculator is actually doing is using the new definition of sine to evaluate sine 156 degrees. It's not using the right triangle definition of sine, because if it were, sine 156 degrees should be undefined. So we're going to see how the calculator finds the value of sine 156 degrees. But before we do that, we just want to introduce some new terminology here. Okay, so let's just look at this circle here. So you can pause the video, study the circle for a bit, and then we'll learn the terms that are in, or the words that are associated with this circle. All right, so what do I have here? I have a circle centered at the origin. The radius of the circle is 1 unit. So this circle is very special. It's going to help us with pretty much all the ideas of trigonometry. So we're going to call this the unit circle. Very, very important in trigonometry. And we want to create an angle, the vertex where the vertex of the angle is located at the origin. If that's the case, you need 2 rays, which we've called the initial arm and the terminal arm. And the way it's going to work is the initial arm, we're going to hold that on the positive x-axis. We're going to keep the initial arm on the positive axis. And if the initial arm is on the positive axis, we say that the angle is in standard position. And all the angles we're going to work with are going to be in standard position. Now, of course, you don't have to put the initial arm there, but we're going to keep it there. So the arm, which is going to move around the circle, that's called the terminal arm. Okay, so the initial arm is pinned along the positive x-axis, and we're going to move the terminal arm around the circle, and that will change this angle here, our principal angle. So as the terminal arm moves, it's going to change the principal angle. Now, there's an angle that's associated with the principal angle, which is called the reference angle. The reference angle is the acute angle between the terminal arm and the x-axis. So a very common mistake that students make is that they measure the angle between the terminal arm and the y-axis. We don't want that. Okay, the reference angle is defined as the acute angle between the terminal arm and the x-axis. And another thing I forgot to mention is that when we move the terminal arm, we can actually move it in 2 directions. We can move it counterclockwise, or we can move it clockwise. And we are going to move it counterclockwise if the angle is positive, and we're going to move it clockwise if the angle is negative. All of this will make sense in our next lesson when we do many more examples. So in this video, we won't do any videos. We just want to talk about the new definition of sine, cosine, and tan, which we're just about to get to. So you can read the definitions of what I just said, the unit circle, the initial arm, the terminal arm. Some textbooks call it the initial side and the terminal side. So don't get confused if you see initial side instead of initial arm. Angle instead of position, we mentioned that. So when an angle has its initial arm on the positive x-axis and its vertex at the origin. Reference angle we talked about. So some textbook, instead of calling it the reference angle, they say it's the related acute angle. I personally prefer the reference angle. And lastly, we have the principal angle, the angle between the initial arm and the terminal arm of an angle in standard position. This angle is between 0 and 360 degrees. All right, so those are the definitions. I would highly recommend you to just read them over and study the diagram because we are going to be using the unit circle quite often. All right, so now hopefully you've mastered the unit circle. I think we are ready to learn the new definition of sine, cosine, and tan. So let's take a look at the unit circle. I have a point P on the circumference of the unit circle. Okay. So it looks like a pretty simple idea. And now, let's see here. Our goal is to describe the position of P as it rotates around the unit circle. You want to describe the position of P as it rotates around the unit circle. So we have formed the angle theta using the terminal arm and initial arm. So, this is very key, we can associate any point on the unit circle with an angle theta. Okay, I'll read that one more time because that was critical. We can associate any point on the unit circle with an angle theta. So if you tell me, I don't know, theta is 74 degrees, that will give me a unique point on the circle. Okay? That will give me a single point on a unit circle. If you give me an angle of 197 degrees, that will give me another point on the unit circle. And here comes our definition. Y coordinate of the point on the unit circle. Okay, so y coordinate point on the unit circle is sine theta. The x coordinate of the point on the unit circle is cosine theta. And tangent is the ratio of the y coordinate of the point on the unit circle to the x coordinate of the point. What if the circle does not have a radius of 1? Can you still find the value of sine theta, cos theta, and tan theta? Absolutely. What we're going to do is use the idea of similar triangles to help us out. So in this diagram, we have point P, which is on the unit circle, and the coordinates of point P are x prime, y prime. And we have another point, point Q, on a circle which is concentric to the unit circle, and the coordinates of point Q are x, y. And we build right triangles, and if you look at the diagram on the right, you'll see the right triangles. And what's the relationship between these two triangles? They are similar. Now, I don't know if you remember proving two triangles be similar in grade 10, but you can prove that these two triangles are indeed similar using angle-angle similarity. So triangle OPA is similar to triangle OQB. And because these two triangles are similar, we know that corresponding sides are proportional in length. Okay, corresponding sides are proportional in length. So x prime over x is equal to 1 over r. Okay, r being, of course, the radius of this concentric circle. So we're going to isolate for x prime. And remember, x prime is the x coordinate of point P, which is on the unit circle, which we defined earlier as cosine theta. So cos theta is equal to x over r. Okay, so if it's not a unit circle, no problem. Cos theta is x over r. You just need to know the x coordinate of the point, which is not on the unit circle. In this case, we were saying it's point Q, and the radius of this circle. What about sine theta? Well, using the very similar idea, instead of x prime over x, we're going to have y prime over y, which means y prime is y over r, y prime being the y coordinate of the point on the unit circle, which is sine theta. So sine theta is y over r. So it works out perfectly fine. Even though you're not working with a unit circle, you can still find the ratio for sine and cos and tan. Now, tan is actually works out very easily, very nicely. It still ends up being y over x, and you can study the two similar triangles to show yourself that relationship. Okay, so in summary, if it's not the unit circle, then sine theta is y over r, and cos theta is x over r. Tan theta will always be y over x no matter the radius of the circle. And what about x squared plus y squared equals r squared? Well, that comes from grade 10 as well. That's the equation of a circle centered at the origin. So the whole purpose of this lesson is just to introduce some new terminology. Like, I'm going to use the words reference angle over and over again. I'm going to talk about the terminal arm over and over again. So just get yourself familiarized with the terminology, and the next lesson we're going to do some more examples.